All right, for this video, we're going to talk about a topic known as indirect measurement. And the first thing we want to do is actually define what that is. Right? Indirect measurement is a method of determining length or distance when direct measurement is impossible. So in other words, if you can't go out and take a yardstick or a tape measure and measure it directly yourself because it's too large or too long or too high, then you have to indirectly figure out a way to make that happen. And indirect measurement is using more proportion. So everything we're going to do is set up a proportion, but now we have pictures that we're going to use or pictures that you can set up and draw yourself to figure it out. All right, so looking at number one, I'm going to do all of these on the front side with you, and then I will do Actually, I'm going to do a couple of the ones on the front side with you, and then we'll flip it over to the back and do a couple of those together as well. Anything that I don't do with you through this video, you are responsible for completing on your own to the point where you come to class with a completed page, both front and back. All right, so taking a look at number one, you see that there are two triangles in this picture. Ignore the whole J2 piece. That's not important for us right now. All right, you see the large triangle that has ABC, and you see the smaller triangle of DBE. When we go to set up, we're trying to figure out what AB is. In other words, we're trying to figure out the distance across the river, but we can't actually use a tape measure because it'll fall in the river, and we can't do anything else other than use some other things we have, right? So what we do have are some measurements in this picture that will help us set up a proportion. And you want to be super consistent with your proportion, right? You want to find matching pieces, right? So you may have to twist some things around in your mind or notice some things that are a little different, right? You see the right angle box on the big triangle, okay? And you see that the letter N is the flat piece along the bottom of it, or the top if you're looking at it upside down. So if we're going to use N first, that's on the big triangle. We need to go to the little triangle and find the exact same spot on the smaller one, right? And because it's the bottom of the right triangle, then the 3 is the bottom of the little triangle. So the N is going to be matching to the 3. Right? So if you need words, this is the big triangle to the little triangle. And we're going to peel the matching pieces out of it. All right, so we've used the N. Now, if you go back to the big triangle, the only other number you can use is the 192, right, which is the long, tall side. So we're going to put 192 on top because that comes from the big triangle. And then we're going to go to the little triangle and find the long, tall side of the little triangle, which happens to be the 8. So the 8 is going to go on the bottom. And there you have the setup of your proportion. So now we're going to do our cross multiplication. So 8 times N is 8N. And then we're going to take 3 times 192, and that's going to give us 576. And we're going to divide by 8 to both sides, and we're going to get N equals 72. And if you go back and take a look at what's been measuring, everything is measured in feet, right? So the value of N is 72 feet. And you can put that up here in your blank, or you can just leave it down here in your work, right? But the answer, that river is 72 feet across. We never would have been able to measure that with a ruler or tape measure or yardstick because there's nothing long enough for that. So we had to use an indirect way of getting there. All right, so let's go ahead and take a look down at, we'll take number 3. Right, and these are common indirect measurement problems. Shadows and people and trees and buildings and light posts. You're going to see a lot of that. All right, so for number 3, you have a 15-foot tall lamppost that has an 8-foot shadow. All shadows are on the ground, so anytime you see the word shadow, you need to draw that piece along the ground. A building casts a 32-foot shadow. How tall is the building? So when it's asking how tall is the building, you can tell where that X came from in the picture. All right, so when they give you a picture, it's pretty nice. It's already set up. When they don't give you a picture, you kind of need to set one up on your own. So when we go to set this up, whatever piece you pick from one triangle, you need to find its matching piece on the other one. So let's go with the 15. 15 is how tall the light post is. Well, how tall is the building? We don't know. That's where the X goes. Go back to the light post picture because you've got to have the same triangle in the same piece. So the top is my light post, and the 8 goes with the light post. So on the bottom, the shadow of the light post is 8, so the shadow of the building is 32. And now you've got a proportion set up. There are a couple different ways to set up the proportion and still get the right answer, so don't panic if your setup doesn't look exactly like mine, as long as your answer is coming out the way it needs to be. All right, so once we get done multiplying, we're going to have 8x equals 15 times 32, which is going to be 480. You're going to divide by 8 on both sides, and we get x equals 60. And if you look back in it, it's all measured in feet, right? So in this case, when it says how tall is the building is 60 feet tall, okay, which is a large building. You would not have been able to measure that with any sort of tool or tape measure that we have. Okay. When you go to do number 4, we'll go ahead and do this one just because it kind of cut it off a little bit. On the bottom of the little square, that's a 12 at the bottom, 12 inches. And then on the big square, that is 120 feet. That got cut off. So let's go ahead and work this one out. It says a path is cuts across a park as shown. A scale drawing of the park is shown by triangle ABC. What is the actual length of the path? So the little one is the paper drawing. The big one is the real park, right? And we're trying to figure out the actual length of the path, which is this dashed line right here. That's what our piece is. So that's where our x goes, right? And if you look at the paper version or the smaller square, we've got enough numbers to do this, right? So you can start with the little one if you want, or the big one. It really doesn't matter, right? I'm going to start with the little one. I'm going to pick the number 12. And if you notice that 12 is on the bottom, so 12 is going to match 120, right? And be careful because the 12 is our inches, because the paper is measured in inches and the actual park is measured in feet. So when we go to do our units, that is important. All right, then we go back to the paper model, which uses the number 20, and the number 20 matches the x that we don't know in the real park. Okay, so there's our proportion setup. Now we want to do our cross multiplying. So we have 12 times x, which is 12x, 20 times 120, which is 2400. Okay, we're going to divide by 12, right? And then you're going to get x equals 200, right? And if you remember that it is the actual length of the path, so it's measured in feet, not inches. So the final answer is 200 feet long. Okay, so you do have to be careful and make sure you're matching up pieces all the way across. All right, if you'll flip it over to the back, I do want to take a look at a couple of these. Particularly, I want to take a look at number 3 because it's kind of hard to read and I want to make sure that you're able to see it. There is a large triangle right here, which most of you can see no problem. Okay, but then there is a small little triangle right in here where I'm highlighting in red. Right, so when you have a triangle stuck in another triangle, you really need to pull them out and have 2 separate triangles. So I'm going to pull out my little separate one in red. Okay, and that one has an 8 feet labeled for the top flat piece and 1 foot for the side. And then I'm going to take my blue one, my big blue one, and it's going to be 50 feet up top and H on the side. That's what we're trying to find. So now you can see a little bit quicker and easier how to set up the proportion with your matching pieces so that it comes out in your favor. Right? So in this case, I'm going to take little triangle to big triangle. So I'm going to set up 8 over 50 equals 1 over h, right? And that'll allow me to figure out what the height of the water is out 50 feet away from the shore. All right, so when we multiply, 8 times h is 8h, 50 times 1 is 50. We're going to divide by 8, and that'll give us h equals 6.25 feet. So it wants to know how deep is the water. It's 6.25 feet deep, that far away from the shore. Okay, so again, when there's a little triangle stuck inside of a big triangle, separate them out so you can see your matching pieces. Otherwise, it does get quite confusing. Okay, all right, let's go ahead across to the 4th one, and then I'll do one more on this page before we go to practice with it in class. All right, for number 4, all right, there's some pieces that we need to figure out. Again, it's another triangle stuck inside of another one, so I'm going to go ahead and separate my triangles. Here's one of them. And then the larger one is going to be my next piece. All right, so with my larger one, I know that the entire bottom is 20, and I know that the side piece is 2.5. All right, that's given to me in the picture. I can see that. Okay, but then for the smaller one, I know that the side is H, that's what I'm missing, but they don't tell me the bottom, but they do give me enough information that I can figure it out. If the entire bottom of the big one is 20, and then I remove this 2-foot section, that'll give me the bottom of the other one. So 20 take away 2 means that the bottom of this one is 18. That's what's going to help you set it up, right? So this is kind of weird in terms of the fact that you had to subtract a piece, right? Most of them you don't have to. That's why I wanted to work this one out with you. So if you go to set up your proportion, right, you're going to end up with H over 2.5 equals 18 over 20. And I'm going to let you finish solving that one and see what kind of answer you come up with when you come to class. So go ahead and finish that one on your own and come up with an answer. Okay. Then I want you to jump to number 6. 5 and 6 are similar to each other, and I want to make sure you understand the difference. Right? They have arch marks in the corners because every angle, it has its own march. So you're really comparing the one with one arch mark is the same as the other guy with one arch mark. So you're trying to figure out the distances between the same arch marks. So when I'm trying to set up these two triangles and set up my proportion, right, I'm going to pick one piece from each triangle. Well, if I pick the D, which is right here, you'll notice that's between the 2 arch mark and the 3 arch mark corners. So if you come over to the other triangle and you find the 2 arch mark and the 3 arch mark corner, the number 32 goes with it. So D matches 32. Go back to the other triangle, right, and you'll grab the number 30, and you'll notice that it's between the 1 arches and the 3 arches. So now we've got to find 1 and 3 arches on the other triangle, and that'll match it up with the 25. So you have to match up not only pieces that are the same, but you have to pay attention to the arch marks and the congruency parts as well. So now take and solve that one, right? And then the last one that we'll do from beginning to end together is number 8. And you'll notice that in numbers 8 and 9, there are no pictures. So if you want to get these right, my advice to you is to draw yourself a little picture. It does not need to be fancy. It does not need to be super great as long as it's got enough information on it. All right, so we've got a statue. So here's our statue. Okay, and it casts a shadow 30 feet long. Remember, shadows are always on the bottom. So here's my shadow. Okay. At the same time, a person, so here's my person, okay, who is 5 feet tall, so that person is 5 feet tall. They have a shadow that is 6 feet tall. And then we're trying to figure out how tall is the statue. So how tall is this piece over here? So now that you see your picture or have your setups, you can match it up a little bit easier and make that proportion happen. Right? So when we go to do our matching pieces, X from the statue is going to match 5 from the person. Then you go back to the statue, 30, which is the shadow of the statue, is going to match 6 from the person. Okay, and then you do your cross multiplying. So you end up with 6x equals 150. Divide by 6, and you're going to come up with x equals 25. Right? And because it's the height of the statue, right, it is measured in feet. Right, but it's a 20-foot tall statue, 25-foot tall statue, sorry, right, which makes sense because the statue should be taller than the person, right, because the shadow is longer than the person's shadow, right, so you do have to set up and draw pictures when it's in word problem format and you don't have them, right, so just keep that in mind for anything that doesn't, but most of the time you will have actual pictures to go from.